when you want to compute inflation rate, you need to look at the current price. You have to look at the cash flow at the cash flow at current prices, multiply that by 1 plus the inflation rate exponent n, which is the n representing the years and the I representing the inflation rate. So this one is the years. Inflation. When a company makes any long-term investment, there is certainly going to be cost and benefits for a number of years. And so in all probability, the future cash flows will be affected by inflation in terms of the costs and the benefits. So in terms of the benefits, the sales revenue or the revenue or the inflows arising out of the project will be affected by inflation, as well as the costs that are involved in the project will also be affected by inflation. So when is inflation taken into account when doing NPV computation? So here you take into account when you take inflation into account when it poses significant effect on the project. So if the inflation has a significant effect on the project, then it should be taken into account. And the next one is when reasonable estimates can be made of the inflation of the future rate of inflation. So when reasonable estimates can be made of the future rate of inflation, then inflation should be incorporated into the NPV calculation. So you realize that it is quite difficult to predict accurately the future rate of inflation for some few years. So mostly inflation are ignored in NPV computation, but when they are significant, they must be taken into consideration. So how do you determine inflation? There are two types of inflation. The first inflation rate is the general inflation rate and the specific inflation rate. Now the general inflation affects all goods and services, but the specific affects specific costs and benefits. So it is possible that within economy, the prices of goods and services, which which is the general definition of inflation. So here, the definition of inflation is appreciation in the prices of goods and services within a specific time. So if the prices of goods and services are increasing, it is possible that all goods and services will increase in an economy by a certain percentage, or some goods and services might increase in prices relative to others. So it is possible under the specific inflation rate that, let's say, materials are increasing at say 5%, but labor cost is increasing by 1%. So specific inflation rate can be attached to specific costs and specific benefits. But the general inflation rate affects all goods and services within an economy at the same rate. And it is quite impossible to have the same or general inflation rate affecting all goods and services. Now, how do you calculate inflation rate? Now, the next thing that we have to look at is what is called the real rate, and the nominal rate. The real rate of inflation and the nominal rate. And when we say the real rate, what do we mean? And when we say the nominal rate, what do we mean? Now, the nominal rate, also called the money cost, makes allowances for inflation. So this means that the money rate or the real rate builds inflation into the cost of items over a specific period. So for instance, if materials were bought at say $100 and it has increased in cost, or inflation of 10% has affected this cost, then for subsequent years this 10% will have to be built back into this cost to have to have the nominal rate for different number of years. So let's look at this one. Let's take it for instance that the material cost, let's say the material cost for the materials cost is 100. For the next 2 years it has increased by 10%, so the next year it will be 110, 120. So the difference is the inflation rate that has affected this cost in this cost, which was the cost of the asset in the previous years. Now let's look at the real rate. The real rate is the real rate, or you say real cost. This is the costs which excludes effects of inflation. So this cost does not include the effect of inflation. It does not build the effect of inflation into estimating the cost of the benefits or the costs associated with the project. So in order to calculate an inflation rate, computation of inflation rate, when you want to compute inflation rate, you need to look at the current price. You have to look at the cash flow, at the cash flow at current prices, multiply that by 1 plus the inflation rate exponent n, which is the n representing the years and the I representing the inflation rate. So this one is the years. Real cost, you can say, is the real cost. The real cost. Okay, so now let's look at another scenario where we are given the money cost and the nominal, we are given the nominal cost or the money cost and the real cost. At what rate should we use in computing? At what rate should we use in computing, or what discount factor should be used in appraising our investment? So the relationship between the money rate and the real rate is established as the international Fisher effect. So we have 1 plus the money rate, okay, is equal to 1 plus the real rate into bracket 1 plus the inflation rate. Now let's take it for instance that the real rate is 10%. The real rate is 10% and the inflation rate is 15%. So in this particular instance, if you want to calculate the money rate, it will be 1 plus the money rate equals to 1 plus 0.10 to bracket 1 plus 0.15. So 1 plus the money rate is equal to 1.10 multiplied by 1.15. So 1 plus the money rate is equal to 1 plus the money rate is equal to 1 plus the money rate is equal to, so 1.10 times 1.15 and that is going to give us 1.265. So if you want the money rate, then we have to group items. So the money rate is equal to 1.265 minus 1, which will give us 0.265 or 26.5%. Okay, 26.5%. So the money rate that includes inflation is the 26.5%. Okay, now when you are doing any investment project, if you build inflation into the cash flows at their current prices, or you decide not to build inflation into the investment analysis, the NPV at the real rate will always be equal to the NPV at the money rate. Okay, so we need to understand that if you do your computations using the real rate and not inflating the cost and benefit, which is under the real rate, you will get a same answer as inflating the price at the money rate and discounting the project using the money rate of return. Okay, Okay. Okay, so now let's look at this question. Let's look at the question on the board and see how we are going to build inflation into the question. Okay. Now the question is a company is considering a project, considering a cost saving project. The company is considering a cost saving project. Company is considering a cost saving project. This involves the purchase of a machine that will cost $7,000, which will result in annual savings in real terms on wage cost of $1,000 and material cost of $400. The following forecasts are made of the rates of inflation each year for the next 5 years. Wages is going for 10%. This means that we have been given specific inflation rate for wages, material costs, and general prices. The cost of capital of the company in real terms is 8.5%. Evaluate the project assuming that the machine has a life of 5 years and no scrap value. Okay, so in order to evaluate this project, since the project is being affected by specific inflation rates, we have to go and calculate the money cost of capital, or the money rate. So the money rate computation. And why do we have to calculate the money rate? We have to calculate the money rate because the project is affected by specific inflation rates. And in order to discount the project, we need the money rate because the money rate makes allowances for inflation in a particular year. Now in the question we have been given the general prices, the general rate of inflation, which is what? 6%. And the real return is 8.5%. So therefore we can calculate the money rate as 1 plus the money rate equals to 1 plus the real rate plus 1 plus the inflation rate. So 1 plus the money rate equals to 1 plus 0.085 into bracket 1 plus 0.06. So this will give us, so 1 plus the money rate will give us 1.15. Therefore the money rate is equal to 1.15 minus 1, giving us 0.15 or 15%. So that is the money rate. The money rate. Now let's go and inflate the costs. Let's go and inflate the costs. So So let's look at inflated variables. So let's look at inflated. So all these are workings variables. So the inflated variables, the first thing that we have to look at is wages, because wages is the first one. So wages. Now, wages in current price terms is $1,000. In current price terms is $1,000, unaffected by inflation of 10%. But if we build the 10% into the computation, we are going to get specific inflation rates. So in current price terms, we can state that inflation, the $1,000 is in year 0, which is $1,000, unaffected by inflation. So here we can state that in year 0, let me make proper use of the space. So here in year 0, year 1, year 2, year 3, year 4, year 5, because the project is for 5 years. But in year 0, the price is what? $1,000, unaffected by inflation. So if we inflate this at 1%, if this inflate at 10%, we are going to get 1,000 multiplied by 1.10 exponent 1, and this one is going to give us 1,100. So year 2 will be 1,000 times 1.10 exponent 2, giving us 1210. Then year 3 is 1,000 times 1.10 exponent 3, giving us 1331. 1,000 times 1.10 exponent 4, giving us 1464. Let me clean here. Okay, so 1464. Then the next one will be for the 5th year, which will be 1,000 times 1.10 exponent 5, giving us 1610. So that is for wages. Now let's go to material savings. I hope you can do that for me. So material savings, material costs. So year 0, year 1, year 2, year 3, year 4, year 5. So in current price, the price is 400. So 400 inflated at 5% will give us 400 times 1.05 exponent 1, giving us 420. Then here, so this is for year 1. Year 2 will be 400 times 1.05 exponent 2, giving us 441. Then year 3 is 400 times 1.05 exponent 3, giving us 463. Then year 4 will be 400 times 1.05 exponent 4, giving us 486. Then year 5 will be 400 times 1.05 exponent 5, giving us 510. Okay, so this is the inflated cost. This is the inflated cost of wages, and this is the inflated cost of materials. The question is, evaluate the project assuming that the machine has a life of 5 years and no scrap value. So is this project worthwhile? What the question is saying, that if we take into consideration this project with the inflation rate and we evaluate, is this project acceptable? Okay, is this project acceptable? Okay, so let's evaluating acceptability of project. Evaluating the acceptability of the project. Okay, so in order to evaluate the acceptability, we need to draw an NPV table for the project. So how do we do that? I think we have already considered an NPV computation, so we are going to go straight forward. There are 5 years for this project, so year 0, year 1, year 2, year 3, year 4, and year 5. Now the first thing that we have to do is the initial investment. So we have to look at, okay, we have to look at the initial investment. The initial investment for this project is the 7,000, which was the purchase cost of the machine. The next is the wages. The wages, and this is what we have calculated. 110, 110, 1100, 1210, 1331, 1464, 1464, 1464, and 1610. Then let's look at the material cost. The material cost. So this one will be 420, 441, 463, 486, 510. Okay. Now someone is asking, why didn't we take into account this one? Because this one is the current costs. But since we are looking at the effect of the inflation using the money rate, the current costs is no more important or should not be considered, because we are using the money rate and the inflated amount, which we shall use the 15% as the money rate to discount the project. Therefore all current price terms will not be relevant. So when we add all of these, this one will give us the net cash flows. So here will be 7,000, here will give us 1520, here will give us 1655, 1651, this one will give us 1794, and this one will give us 1950, and the other one will give us 2120. Now we need to discount, so the discount factor here is the 15% that we calculated here. So 15% at year 0 will be 1 over 1.15 exponent 0. This will give us 1. So for year 1, we change this one to 1, and that one will give us 0.87. So here will give us 1, here will be 0.870, this one will be 0.5, 0.756, 0.658, 0.658, 0.572, and this one will be 0.4497. Okay, now let's look at the present values. So this one will give us the PVs of cash flow. So obviously this one is going to be 7,000. This one will give us 1332. Sorry, this one will give us 1322. This one will give us 1248. 1248. This one is 1180, and this one is 1115, and this one is 1054, and this one is 1054. Okay, so now let's find the NPV. So let me move this one here, the NPV of the project. So let me move all this one. Okay, so the net present value, so the net present value of the project, so the net present value of the project will be minus 7,000 plus 1322 plus 1248 plus 1180 plus 1115 plus 1054, and this is going to give us a negative net figure of 1081. So it means that this project, which is less than 0, so this project should therefore be rejected. So that is how we incorporate inflation into a project.